So we're going to do number 1 on today's worksheet. Chlorobenzene is used in the production of chemicals such as aspirin and dyes. One way that chlorobenzene is prepared is by reacting benzene, which is C6H6, with chlorine gas according to the following balanced equation. So question A is asking for what is the theoretical yield of if 45.6 grams of benzene react. So that's 45.6 grams of this stuff. And the point of this question is that you're trying to produce chlorobenzene. So you really have to get that from the question itself. So what is the theoretical yield of that? So let's just start doing some stoic. So 45.6 grams of C6H6, we got to convert that into moles. You got 6 carbons, so that's 12.01 times 6. And then you got 6 hydrogens, so that's plus 6.06. 6.06. And 78.12 is what I get. So 78.12 grams is 1 mole of C6H6. So the number of moles is 45.6 divided by 78.12, and we get 0.584. So 0.584 moles of C6H6. We are interested in this, though, so we got to do the molar ratio between those two things. Luckily, it's a 1-to-1 ratio. So 1 mole of C6H6 will produce 1 mole of C6H5Cl, which just means you're going to get 0.584 moles of that stuff. And we got to convert that into grams. So one last step. We got to add up all the pieces here. So we got 6 carbons, so 6 times 12.01 plus 5 times 1.01 plus chlorine, which is 35.45. I get 112.56. All right, so let's multiply those two numbers together. 0.584 times 112.56, 65.74. Let's zoom in here. 65.74 grams of C6H5Cl. That's our theoretical yield. So if we only got 63.7 grams of that stuff, let's just do the percent yield. 63.7 divided by 65.74. 63.7 divided by 65.74, and we get 96.9. 96.9% yield. That's pretty darn good. All right, and that's how we do number 1. Okay, we're doing number 2 on the second sheet. Write a balanced equation for the reaction of iron 3 phosphate with sodium sulfate to make iron 3 sulfate and sodium phosphate. Okay, that's a mouthful. First things first is we have to come up with the correct equation, and then we're going to have to balance it. So this is going to be multi-steps here. Iron 3 is going to be Fe with a 3 plus, right, because that's what the 3 means. Phosphate is PO4 with a 3 minus, and you can get that off of your list of polyatomic ions. Phosphate is PO4 with 3 minus. Sodium is a plus 1. Sulfate is SO4 with a 2 minus. And now we just kind of have to sort of balance these things out. So iron phosphate, like these things together, are pretty easy because the charges are balanced already. So this is going to be FePO4. So we don't know the coefficient yet, though. I'll just leave that blank. And sodium sulfate, we got to balance out those charges, so we're going to need 2 sodiums to do that. And it's going to make iron 3 sulfate. So remember, iron 3 has a plus 3 charge. Sulfate has a minus 2 charge, so we are going to have to balance those out. So we're going to have 2 irons to balance out 3 sulfates. Right, so that's what that would look like, because we got to get these charges to balance. And sodium phosphate. So sodium, we're going to need 3 sodiums to balance out a single phosphate, right, to get this. and this to balance out. Okay, that takes care of the formula, but we got to still balance it. So let's try a couple things right here. We need to have there's three sulfates on this side right here. Let's do this in green. We got three sulfates here. Let's put a 3 right here to balance that out. That'll balance out the sulfates, but now we got 6 sodiums. So let's balance that out by putting a 2 right there. Now we got 2 phosphates. So the sodiums are okay, but now we got 2 phosphates, so we put a 2 right here, and that looks like it's all balanced. Okay, so that takes care of our first job, coming up with the formula and balancing it. So if you perform the reaction with 25 grams of iron phosphate and an excess of sodium sulfate, how many grams of iron sulfate can you make? So this is not going to be too difficult. It's going to be 25 grams of FePO4. Let's convert that into moles. So iron is 55.85. That P is 30.97 plus 4 oxygens, which is 64, right? 16 times 4 is 64. And I get 150.82. Now that I do this number, I kind of remember this problem from yesterday, or at least this part of it. So this part is kind of repeat. So 25 divided by 150.82 is 0.166. So 0.166 moles of iron phosphate. We are interested in creating iron sulfate, so we are interested in that relationship. It's a 2-to-1 relationship. So 2 moles of iron phosphate will create 1 mole of Fe2. I'm not going to write the whole thing out, but I can see that it's at Fe2. So 0.166 divided by 2, 0.083 of Fe2SO4 And now we just have to convert that to grams. So let me just zoom in here because I'm kind of running out of space. So let me add up all these pieces now. So I think Fe2, don't want to forget that too. Okay, so 55.85 times 2 plus 3 sulfates, so 3 times 32.07 plus 12 oxygens, so 12 times 16, and I get 399.91. So 399.91 grams per mole of that stuff. So 399.91 times 0.083, and I get 33.19 grams. So this is the theoretical yield. This is how much you should get. Theoretical yield. Okay. But what if you only made 15.75? Well, that's okay. So 15.75 divided by our theoretical yield, so actual divided by theoretical. 15.75 divided by 33.19, 47.45%. 47.45% yield. That's what we get. So part C, if you do this reaction with 15 grams of sodium sulfate and get a 65% yield, how many grams of sodium phosphate will you make? So what we're interested in doing here is taking a look at this now. It's a little bit of a change. We're going to focus on the other ingredient, or the other reactant, and figure out how many grams of sodium phosphate we should make. And so in this case, we will assume that the sodium sulfate is going to be the limiting reactant, because that's just sort of the way that the question's worded. So let's do this in purple. So sodium sulfate, so Na2SO4, let's convert that to moles. Sodium is 22.99, so 22.99 times 2. And then the SO4 part, so S is 32.07 plus 4 oxygens, which is 64, so 142.05. 142.05 grams will be 1 mole of that stuff. So 15 divided by 142.05, we got 0.106 moles of sodium sulfate. We are interested in the relationship between sodium sulfate and sodium phosphate. Luckily, well, not luckily, but that is a 3-to-2. If I take a look up here, it's a 3-to-2 ratio. The 3 moles of this stuff will produce 2 moles of the other stuff. Sort of this 2 versus 3, just to remind myself of what these represent. So it's going to be 0.106 times 2 divided by 3, 0.07, we'll call it 0.071 of Na3PO4. So how many grams should we get of this? So we got to convert this to grams. Again, I'm kind of running out of space right here, so I guess I'll do this pretty small. So Na3 is 22.99 times 3, plus a single P, which is 30.97, plus 4 oxygens, which is 64. That's 163.94. 163.94 grams per mole times 0.071, 11.64. So this is, you should get 11.64 grams of this stuff. And now let's go back to remind ourselves of what we were trying to, this is the theoretical yield. So it says that we get a 65% yield. So this is how much we should get. So what's 65% of that? Just multiply it by 0.65, right? So 1.64 times 0.65, and we got 7.57. 7.57 grams of Na3PO4, and that is what we get.